Okay, so let me recap that for the folks on the Blue Jeans stream. We're going into the unconference session now, and we're going to start with a couple of demos, one of which is going to be a recorded stream from our education director in excuse me. It's got to that time in the afternoon, I've lost my command of my only language. So, LCO's education director is based in the UK, and his name is Edward Gomez, and he's building a TOM. He's doing it for a slightly different purpose for some of our education users. And before I go into the live demo, I wanted to point out that he has written a TOM for Education package. This is a separate repo from the main TOM toolkit, but it is also open source, so you can pip install this if you want to use any of the features that you're about to see. And yeah, okay, so let me set up. Actually, you know what? I need to set up the audio stream so that you'll be able to hear this first. Yeah. Can you go into the live demo? Because I need to get the audio set up here. Oh no, is Samuel here? Perfect, okay. Let me send this and I will add the speakers here. Sorry, this is what you get for doing a live demo.
Hello, everybody. My name is Samuel Wyatt. I work with David Sand primarily at the University of Arizona. For the past 5 or 6 months or so, we've been working very closely with Yair and some couple of other faculty, mainly from LCO, and Aaron Tohovahu at the University of Toronto. And we've been working on this treasure map concept, which is pretty much like the main motivation behind it is going to be have a more collaborative effort. Oh, here's Yair if he wants to give the primer more or less. I was just telling you, or I was just going to go into like the motivation behind it.
Can you put up the alerts, the 25Z one? So the idea, of course, being gravitational wave event happens, and we all want to find a counterpart as quickly as possible because there's a lot of physics to learn from the first hours, but we're all scrambling independently using a lot of observing resources and maybe, well, very likely overlapping our searches and not being very efficient in covering the whole region. So coordinating between, 70 different astronomy groups to tile a region that's maybe a few hundred square degrees or 1,000 square degrees on the sky is a very daunting task, and we're not doing that. What we are doing is at least providing a way for people to report where they are observing in an easy way, and for people to be able to get that information in an easy way, and then make their own decision about whether, do I want to tile the region that's already being tiled by 10 other groups, or do I want to look at a lower probability region and where no one else is looking? I mean, that decision is yours, but at least you should have the information of where people are looking to make that decision. Or if you're not a part of this game, but you just want to sit back and see what's happening, you can do that as well. So here you see an example of one of the gravitational wave events from April of this year. So you see the localization region, and you see a bunch of pointings from different telescopes. So can we put up the legend? So there are different types of telescopes, some who do tiling, some who do galaxy searches, and you can see this is just a small number of the telescopes that search this region, but already you have here a graphical interface where you can see where people looked and what areas we missed and what areas overlapped. And the first step, I think, in doing this more efficiently is being able to share what we're doing. Now, people are willing to share this information. They send out GCNs with lists of 50 RA index that they're observing, but this format is not something we can really use in real time to direct our searches. So the idea is to facilitate that. So Sam, who wrote all of this, will explain a bit how this actually works.
Thanks, Yair. So the main thing is that what we want to do is we want to have a group of users who are doing these optical searches for these events to create an account and be able to push or subscribe to whatever they're pointing to, and so that the community can pull from there. So the first thing that we actually did was actually develop a really functional API to where you can query all of the pointings for a given gravitational event, and you can also post your own pointings there. And so you can programmatically see what other people are looking at. So we have all the documentation for that here. The main things that we have right here are the pointings to where you can post your own pointings, and we have a good Python example right over here to the right, and then over here to the left, it has a very well documented all the parameters that go into the method. And when there's two different ways you can post your pointings. You can say that, hey, we plan to look at maybe a good portion, a good tiling of the localization area. So you want to post your pointings as, hey, we think we're going to look at this at this time. We think we're going to look at this next area at a different time. And then when you finally look at those pointings, you can update them to be completed so that the community can know, hey, we know that this group looked there. Did they find anything? Maybe not, maybe so. And the other API method is a good get method. So you can query based of all these parameters, whether or not it's been completed, planned, all these date times as well, and different photometric bands, and all these other different parameters that are right here. But that's just a simple URL based query, and it returns everything in a JSON format. Once you do that, say you want to become a user, you want to create your own pointing, you can also do it through the web page itself. So, I have this account. Oh, that's not the password. Yeah.
In the meantime. So the way we envision, I mean, this is already live. We haven't officially announced it yet because we're still tweaking the front end and making it a little prettier. But all the back end works. So if you want, you can go right now to treasuremap.space. You can request an account. And then the first thing you need to do once is submit your instrument if it's not already there. There are several instruments that are already there. So you submit an instrument and you define what the footprint of your instrument on the sky is by defining this polygon. So we know, if you have a rectangular polygon or some weird shape, and we have, Sam has put in like the ridiculous DECAM, different CCD tiling with all the gaps in there. So it has all of that already. So you can make your instrument, you do that once. Once you do that, you submit it, you get an ID, and from that point forward, your code can submit, whatever. You have 1,000 point. The alert came in, you decide, I'm going to observe these 1,000 pointings. It's one line of code to submit that to the treasure map as planned, and then once you observe them, you can say which ones have actually been done, and you can also, with one line of code, query what other people are doing and use that in whatever way you want to decide your strategy. And you can also do it through the web pages. So you can also, if so, even amateur astronomers can use this to just submit specific pointings or get specific pointings for an event, and do whatever you want with this information, which is obviously much easier to parse than stuff in a GCN. So we're hoping, our plan is to announce this for the second part of O3, which will start in November, and integrate it. Hopefully, all the search surveys, or most of them, will integrate it into their triggering so that they automatically report here. And anyone, you don't need an account to see what's going on. You only need an account if you want to report stuff, but you can just sit back and see what people are doing and see how the map updates in time. And then the next step is to start calculating statistics of how much of the probability region has been scanned, adding galaxy catalogs to see which galaxies had been covered. And in a second version, we're hoping to add also tracking of the different candidates that have been found in these regions. Where are the candidates that people are reporting, which ones have been classified, which ones have not yet been classified, so it's easy to keep track in real time. Yeah, sorry.
Just mainly like creating an account. There is like a button up here, but I can't access it through the I don't know how to make this smaller maybe. No. But yeah, there's like a register. Yeah, it's fairly simple. Is there a way to move that? Here it is. Okay. So yeah. So here, yeah, if you want to log out, it has a nice register button right here, and you just put your name, last name, and then after you register your account, you'll be asked to verify it. And once you verify it, you will get an API token that you can push and access all the functionality through the API. And the API is pretty friendly. It lets you know if and or what you do wrong. And feel free to, if you do want to do this, just email me if you have any problems. It's my email's on the front page here, so, or it's not actually. Yair's is. So he'll probably forward that to me. Yeah. Yeah, it's usually the way to go. But that's pretty much it. If anybody has any questions, we're welcome to field them. Yes, please use it.
Okay. So, fingers crossed, we get some interesting feedback. I'll tell him use that. So the reason I wanted to show... Okay, the reason I wanted to show that is because, of course, you could imagine plugging your own data pipelines into that same structure that enables you to then trigger something to run in the background. And I believe we have tutorial information on that. So please nod. Thank you. Okay, so I will hand back to Wes for the rest of the session.
Great. So, don't know. Okay. Anyway, so at the beginning we were asked if you had any ideas for proposal ideas to submit these and then stand up and pitch today. But despite the pitches happening now, the proposal ideas are still being accepted. So if something dawns on you and you want to work with some folks on something like that, please go to this link and submit them there, because that's the place that everyone will be able to see them. Is this on? I'm not sure if we're actually speaking to someone here. Regardless, there are 3 pitches that have been proposed so far. I'm not sure which one's first. Juan, if you could come on up and tell us what's up. Hopefully it's on.
Hi, my name is... pretty quick. It's Juan Luna. I'm from Argentina. And I don't know if you are aware that most of the alerts that we get from the brightest nova, we got it from amateurs, not from surveys or brokers. I mean, 2 weeks ago, there was a bright nova that reached magnitude 6, and it was the alert came from a Japanese amateur. And spectroscopic follow-up is, of course, necessary, but because of these alerts that come from an email, most of the observations are repeated, and that needs to be optimized. So the idea for the proposal is just to start building a TOM base for the amateurs to try to put their alerts through a TOM and then observe these novae with some telescope that we can get. And the more ambitious part of the project would be to provide the amateurs with a way to upload their alerts or encourage them to use the TNS that what should be, or people think that they should be doing, but they are not doing, and coordinate with other facilities too to make simultaneous observation, like Chandra plus OR. So usually the alerts goes, so the amateurs alerts in the optical, and then a group of professionals like the SWIFT NOVA group triggers observations in X-rays. But then once the observation gets scheduled in X-rays, we don't have a feedback for the amateurs to continue to observe in the optical simultaneous to X-ray missions. So that's another goal of the proposal. So if you want to talk to me, that's my email, and I hope you join. Thank you.
Konstantin, you're up.
Hello. You have already heard about this stuff, but I would like to repeat it. My idea is to add some cross-matching application for TOM. So we could have cross-matching results with various existing catalogs on a target web page of our TOM website. It could be useful in different situations. For example, if you study some extragalactic source, you probably would know what a host galaxy is and what is known about this galaxy. And this is the first point. The second point, for example, you have some transient in some galaxy, and it looks like a supernova, but you can find in some catalogs that, or in some paper data in Vizier, that it's known AGN, for example. Yeah, then you think, okay, it's probably not supernova, but AGN outflow, outburst. Sorry. For galactic variables, the same thing. I will not repeat. Only a few words. You will probably you would like to know if this source is a part of some cluster, stellar cluster, and probably you would like to know is this if the source can be corresponded to some known variable star. And development goal is to develop such TOM app and think about how it should show you these cross-matching results. So outline is as following. First of all, our team, SNET team that I'm part of, have some website that we use for analysis of ZTF DR1 light curves, and you can try to scan this QR code. I don't know if you can, but you can try and see some examples, and you can use search and so on. It's very, very early stage of the project, so it's slow and maybe buggy, but it shows what stuff you probably would like to know about variable star of our galaxy. Yeah, and what catalogs you would like to cross-match with if you study some variable from our galaxy. And then some steps that should be done while developing. For example, we can try to program some thin proxy between AstroQuery, Python model, Python library, and TOM. Then some existing purple catalogs should be added as Simbad, Gaia, SDSS, and so on. Probably this cross-matching interface should not be limited to cone search, but probably you'd like to provide some additional information such as redshift or magnitude or something else. And probably if you found some cross-matching object, you would like to get its properties and to use them to your objects that you study. For example, you found some host galaxy, you should have simple way to copy its name, its coordinates, and so on, its properties to the object that describes your target. That's all. Thank you.
And last but not least, Melissa, please come on up.
Oh, there's still only three. Hello, I'm Melissa Graham. This morning I talked to you a lot about the LSST, bombarded you with information, but my first slide this morning was about the Astrophysical Research Consortium's 3.5 meter telescope, which is classically scheduled but remotely operated. And it's about 6 to 8 different institutions that are partners in the ARC, the Astrophysical Research Consortium. And this particular telescope, this particular 3.5 meter, remember I said all the instruments are hot and always ready. You can do quick instrument changes. And it's got a suite of imagers and spectrographs. And this makes it quite good for time domain follow-up. And we're trying to figure out how to make better use of this telescope that is well suited to time domain astronomy, but it's not robotic, so it's still classically scheduled but remote. So what we'd kind of like to do is use the TOM to make a sort of pseudo queue that everyone who's within this consortium who wants to sort of participate in time domain follow-up and share targets and make sort of the best use of the conditions at the time and sort of do a grassroots queue service type of observing where we all sort of can work together. I think that the TOM could be an easy way for us to share our follow-up targets. in order to use, for example, gaps in schedules of people doing static sky programs or bright backups for poor weather, or just doing transients and variables under an umbrella program for that kind of thing. So, I mean, I understand that this doesn't make use of all the greatest parts of the TOM toolkit, which is the interface with brokers and then the automatic interface also with observatories, so that we couldn't like submit things automatically to this 3.5 meter. But I think there's a lot of telescopes out there in the world that are still being classically scheduled and being classically observed and can't afford to have queue service and want some way to make better use of their time. So some kind of TOM like this, I think you'd want the capabilities like make it very easy for people to input their targets, be able to just specify observing conditions and customize instrument configurations just like a queue, except it just doesn't quite connect. The endpoint is a person who's just printing out a star list and using it during their night. It's not going directly into the observatories like observing software. So I would also like to build some kind of TOM that can do target filtering. So sort of like on-the-fly target filtering for the current instrument configuration, what's accessible from the site and what's bright enough. And just people can just make a quick list to see what they could maybe spend their time on right now. The ability to automatically make finder charts is really helpful in this situation. Having target expiry dates so that when people put things in, they can leave it in for a month, and if it doesn't get observed, it can just sort of delete itself. Right, and then outputting things in a star list format. So if you're in this kind of situation where you're trying to make use of classically scheduled time and you want to maybe help me or help some of us make this kind of super basic TOM, then I would love that. Yeah.
Sorry, there was another one. Rodrigo, great. But how many more are there, Rachel? Just the 4? Cool. 2 more. Great. Thanks.
Okay, thanks. Hi, I'm Rodrigo. I'm from the National Observatory in Brazil, Rio de Janeiro, and I'm part of a very active group that works with stellar occultations by TNOs. So here I bring you a slightly different problem that can be analyzed from the alerts that we are obtaining. I'm showing here you a prediction map. So what we do is we take the astrometric positions of solar system objects and then we predict when they will be occultating a star, and in such a way that we can actually capture this projection on the Earth. This is today on Earth-based telescopes. This is the most accurate way that you have to establish sizes and this kind of stuff on TNOs. But we need very good astrometry to perform this. So there are some very interesting science goals that we can do during stellar occultation. That is, we optimize their orbits so we can better know their orbital parameters. We can characterize them, sizes, shapes. We can make atmospheric studies when they have atmospheres. It presents. You can see actually the light being bending when he passes in front of the star. You can, knowing that, since they are very distant solar system objects, you can actually have a better comprehension of the early solar system because of their composition, since they didn't interacted very much with solar radiation, and better comprehension also on dynamics, analyzing their distributions, orbital distributions, and so on. So what will be interesting is that once you can feed these predictions from ZTF, we already have a platform that does it. We actually analyze all the DES images and we run predictions on it, and we broadcast this information since we work with a lot of amateur astronomers. Here you can see it's like it were like 80 telescopes observing this occultation. So we could actually we are interested in feeding ZTF information and the LSST information into this platform to perform these predictions, and maybe using the TOM systems to actually schedule the occultations, because we can predict them. This is a problem that it's time critical, because it will happen in a very defined time. Our only problem is that we need very high cadence. So this is I don't know how, for instance, LCO would actually could be used to do so very fast exposure images. And combining this with light curves, if you observe this object and you can determine its rotation, you can actually, during the occultation, measure exactly the side of the object, and then you can create very precise 3D models, and then you can extend and study its volume, compositions, and from rotation you can study minimum densities and so on. So you can perform a very broad characterization. So, well, basically this is the idea of what we are actually very interested in doing. Thanks.
Good idea. Finally, Taurus, who is great, thanks.
Hi, I'm Mariano Dominguez from Cordoba University in Argentina. I will catch your attention about a number of software packages that we made inside the Torus collaboration. The Torus collaboration, we are building a small telescope in order to follow up the LIGO and Virgo triggers. We are catching kilonovas, have all the people here. And also, we made some useful tools. For instance, I think that could be useful for all the tools that we are made inside the TOMs and the brokers, and could be useful for you. The first one is a Corel framework. This is a framework for do pylons. It's very simple, all written in Python. All the code is freely available. All these publications are made on astronomy and computing and well documented, read the docs and all the stuff. The other tool was a comparison really about the different imaging analysis method. We compared all the most popular methods, Bramich, Sakai, and also we compare before and after apply machine learning techniques, standard classical machine learning techniques. That could be useful if you would like to make some different image analysis. The code is well documented too, and you could find all these codes on our GitHub repo. And finally, recently one of our students made an improvement on the methods for extract features, classical features of course, for machine learning from light curves. All these three projects are made inside the Torus collaboration, which is led by astronomers on Texas, University of Texas at Rio Grande Valley and Texas A&M, and also Cordoba. And also recently we are starting to make, this is a different project, we are making weak length analysis. I'm working mainly on extragalactic astronomy. We are studying nearby emerging galaxy clusters, but we are using the hyper supreme time at Subaru, which actually, in order to reduce the data, apply the pylons developed for LST. We are trying to introduce, for instance, new methods in order to make the corrections for the variability on the PCF in a wide field. And this was made previously by the collaboration in order to apply the different imaging techniques. And actually, we are trying to learn in order to prepare for the LST. That's all. Thank you.
So that was it for the pitches. There is, for the remainder, I guess the hour we have left, we'll jump into some breakout groups here. Now, 15 minutes, is it only 15 minutes? Wow, okay, short discussions. How about we start these discussions today and carry them on through tomorrow. So well, it's not actually written there, but all of the things that were just pitched are either proposal ideas that should be discussed while you're here if you're interested, or Taurus to talk about that as well. But here are the things that people have suggested in the other document of what breakout sessions we could talk about here. And some people have already been voting, the most popular being the first one. I think we're all very much interested in the capabilities of Antares. And so the idea is we're going to look at all of these and vote, and then I guess for the next 15 minutes I'll send you to your respective rooms, either the library next door or in the basement, and give you a chance to start chatting with like interests. And so I'll give you a sec to read through all of these. The names have been omitted so that no one is sort of called out or whatever. So if you have questions about something like this, I'm not the proposer on any of these, so I can't really answer your questions, but we'll have a quick 30 seconds to read over these, and then we'll vote about which ones we'll go talk about. We have a Jeopardy song right now. You all had a chance to look over them? Good, okay. Antares. Put your hands up if you're interested in talking about learning about writing your own filter for Antares. Okay, there's a few. How about alternative metrics for observation request priority? And so this is beyond the IPP as far as I can tell. Similar number, okay. Universal cross-matching? Okay, Tom as a user interface for human-assisted machine learning. That's a mouthful, right? Okay, code hacking session. Who really wants to continue on with what we've been doing before? Of course, I knew you would. And then, do you want to start writing proposals? Now is your chance if you want to work together in groups. And then finally, a tool to display telescope locations and pointing limits. Right, you see, this is exactly what I was afraid of. These four and the bottom one are all equally popular. All right, so we've actually got 4 rooms, but go ahead, Rachel. Yes, definitely. Yeah, there were more votes online than there were hands up in here. So this one's going to go to the library. I think there's the most chairs in there, actually. Oh, yeah, okay. So what would you like for the last 10 minutes then? Oh, I see. Okay, so here we are. Library, next door, basement, right here. Okay, just repeating one more. Library, next door, basement, right here. Choose your poison.